Welcome back to this video lecture series on data structure and algorithms. So today we'll be seeing on the deletion in AVL tree. We have already known how to insert some element in AVL tree and what is the main functionality of AVL tree. Today we'll be seeing how to delete a node from the AVL tree. So let's first concentrate on the steps that we need to follow in order to perform the deletion operation in AVL tree. The first thing is that we have to perform the normal binary search tree deletion, and the current node must be ancestor to the deleted node. Now we have to update the height of the current node, and then again we have to get the balance factor of the current node. Balance factor is nothing but the difference of height between the two subtrees of the current node. Now if the balance factor is greater than 1, then the current node is unbalanced, and either it is in left case or left case. And if the balance factor is lesser than -1 and the current node is unbalanced, and then it is either in right case or right-left case. So this is an example of deletion of AVL tree. So basically what we need to do is we first need to perform the normal binary search tree deletion, and then we have to see whether the tree after deletion keeps the nature of the AVL tree. If it does not, then we have to make it an AVL tree, that is we have to do the self-balancing thing. So suppose this is the tree we have and we want to delete this 10 node. Now according to the binary search tree deletion, we see that the node to be deleted has 1 children. So what we do, we copy this children node to here and we delete it. So what we will get an unbalanced tree where there will be only one right child to this root node of the tree. So suppose this is now 11. So after deleting the node, the tree is like this whole part remains same and only this node remains. There is no node here, and suppose this is 11. Okay, so we can see if this is the case, then there is a unbalanced thing, like the height difference between two subtrees will be greater than 1. To avoid that, what we do, we see that this is a left case, so we do a right rotation, and hence we find this tree which is a balanced tree, which is an AVL tree, and here the node 10 is deleted from the tree. Now we will jump onto the programming part and see how we can implement it. So I have opened my IDE and I have already opened the code I wrote for the insertion operation of the AVL tree. The thing is that in that program we actually created an AVL tree. Now using that program only we will be deleting a node. So what we will do, we'll first perform this delete node operation. So for that I'll use this function, let's name it delete node, and the arguments will be the root node and the value to be deleted. Let's say we want to delete 20. After doing this, I'll be printing a message that pre-order traversal of the AVL tree after deletion is, and just copy these lines. That's it. So the main task for this program is to define this delete node function. So let's go on to the definition part. So the return type will be struct node star. Here's the function name. The arguments will be struct node star, let's say R, and let's say this will be val. So the basic binary search tree deletion. So if R happens to be null, then we simply return the root node. Now if value, that's val, is less than R data, then R left is equal to, we do a recursion call here on the left subtracer, left, and the val. Else if the value is greater than the R data, then R right is equal to delete node, a recursion call on the right child and val. Else, now here we need to consider the situations where whether there is single child or double child. So first is if R left is equal to null, or R right is equal to null, then what we first do, we create a node, actually a temp node. So struct node star temp, and we use if R left, that is if R left is not null, then we choose R left, otherwise we choose R right. Simple. Now if temp is equal to null, then temp is equal to root, and root is equal to null. Otherwise we copy the whole of the node of the temp to the root. So star root is equal to star temp. And lastly we write free the temp. And in the else part we'll encounter the situation where there are two childs. So we'll again first create a temp node. So struct node start temp, and here I'll store the in order successor. So for that again we will be using this in order successor function, and I'll pass the right child here. So let me just define this function first. So the return type will be struct node star, and then there's this. Again the argument will also be struct node star R, let's say. So here I'll make a demo node, demo is equal to R. Now I'll run a while loop, while demo left not is equal to null. What we do is that demo is equal to demo left. Finally return the demo. That is the in order successor function. So after getting that, what we do, we copy the in order successors data to the root. So R data okay, I have been using root here, so there will be these changes. This will be R only. Yes, I have passed R here, so that's a slight mistake. So this is, so R data is equal to temp data, and lastly I'll call a recursion call on the right child of the delete node function again, sorry. So R right, and the key to search would be temp data. That's it. Now if root is null, then we say return root. Now after that we need to do something which is very similar we have already done in the insercer function. We first have to update the height, get the balance factor, and check for the left or left right or whatever conditions, and do the rotation things. So as I have already written down those lines of code, so I'll go to this insert function here. Here is it, and I will copy from this portion. Here we first update the height, next here we get the balance factor, and then from here until up till here we do what is we do the balancing thing. So let me just copy it down, and I'll be pasting it right here. Here it is. So the delete node function is completed. Let's now save it and run it. So here is the output. As we can see, we took this tree 30, 20, 10, 25, 40, 50, and we asked to delete this 20 node from the tree. And as we can see, the output comes, the node has been deleted properly. So this was the code for the deletion of a node from the AVL tree. Thank you for watching this video and staying with us. See you next time.